Okay, so a video looking at how high somebody or something, a projectile will be thrown if it's launched from a spring. Well, let's first of all consider what exactly we're doing. We've got a spring like this in some kind of launch platform. Could be a trampoline, but we'll represent it as a spring, and that's it in its rest position. Now what happens is we are saying that we are going to compress this spring so that it's like this, where our compression here, change in length, we'll still call it x, is that amount there, and that should be the same, it's a little bit off. Okay? Now, if we're looking at launching some kind of projectile, so I don't know, somebody can be stood on there, human cannonball, it's someone jumping on a trampoline, then what we're looking for is how much energy are they going to get from this trampoline. So the first aspect, this question comes in two parts really. The first part is finding out how much EPE is stored by that spring. And to do that, we know that EPE is equal to half Fx, and since we know F is equal to Kx, we also know that's a half Kx squared. So let's think, if we assume that we have a spring of constant, just going to make some numbers up, let's say K is equal to 3,000 newtons per meter, and let's say we go for an extension of, I don't know, the compression here, if X was equal to 20 centimeters, remember we're going to convert that straight away into meters, 0.2 meters. How much EPE will that give us? Well, the EPE, we know it's going to be half Kx squared, it's going to be a half times 3,000 times by 0.2 all squared. 0.2 squared is 0.04 times by 3,000 is 1,200, which gives us a total amount of joules of 600 joules stored by compressing that spring. The second question, and this question really can take two parts. The second question, it assumes we're going to transfer all that. So we're going to transfer all, the assumption here nearly always is all the EPE into something else. Now the two questions that most commonly come up are transferring it into kinetic energy, so how fast, what's the very fastest that this person, this projectile will launch given that much energy, so we use the formula for kinetic energy, half mv squared. We have to, given that we know the mass. The other question is, how high will they go? Well, in that case, what we're doing is we're transferring all of this EPE into GPE. So let's say we're going to do that part of the question. So how high will this person go? Well, if our person has a mass of, I don't know, just make some numbers up, it's a small person, 60 kg, then its weight is approximately, this person's weight is approximately 600 newtons, and we know that GPE equals weight times, well, actually mgh, we know it's equal to mass times gravity times height. Well, if I'm saying that GPE is going to be equal to 600 joules, it's starting to get a little bit messy down here now, then what I know, well, what I can work out, if you remember, its GPE was 600 joules, change colour again, so 600 joules equals mgh, mass is 60 kilograms, g is 10, we can find that h is going to be equal to 600 divided by 600, 1 metre. So that person of mass 60 kilograms, if they were to stand on that spring that had been depressed by 20 centimetres with that spring constant, they would be shot into the air at a maximum height of 1 metre. In reality it would be much less than that, because obviously the assumption that all EPE turns into GPE, so the assumption that all the EPE goes to GPE of course is incorrect, because there will also be heat loss due to friction, maybe some sound, but there will be energy lost elsewhere. So ultimately he's going to go less than 1 metre up. Okay, hope that helps.